So today we're going to be solving logarithmic equations. We're either going to have one logarithm or two logarithms in the problem. Our goal is to figure out the value or values of x that make the equation true. So if you look at this one down here, you'll notice that they both have a log with a base of 5. So the only way that this equation can be true is if whatever you're evaluating the log of equals whatever's in the log of the other side. So for this one, x has to equal 8. So let's go ahead and dive a little bit deeper into this and figure out how to solve logarithmic equations. So our first step we're going to do is we're going to get the logarithm by itself. So looking at number 1, the logarithm is already by itself. Now looking at this, log base 81 of x equals 3/4, our brains aren't really programmed right now to look at a logarithm and know what that is. We're more used to exponentials. So what we're going to do is we're going to get this as an exponential instead of a logarithm. So the inverse operation to a logarithm is to exponentiate. So what I'm going to do is I'm going to figure out what the base is. So the base is 81, and I'm going to exponentiate both sides using that base. Meaning, I'm going to write 81 as the base on both sides. 81 to the log base 81, those are inverse operations, which means on the left-hand side, all I'm left with is x. On the right-hand side, I have 81 to the 3/4 power. Okay, so that's called exponentiating. And now that I've written it in exponential form, I can actually figure out what x equals. So we can take and rewrite this using our x root of 81 cubed. The fourth root of 81 is 3, and 3 cubed equals 27. So the answer to number 1 is 27. We're going to go ahead and check our answer. If you can imagine plugging this in to your equation, the log base 81 of 27 is 3/4. So as a brief summary here, I wanted to show our steps. Okay, so step 1, get the logarithm alone. 2, exponentiate both sides using whatever base is in the problem. Step 3, you solve the equation and then you have to check your answer. So the two things that we'll talk about upcoming are you cannot have a negative. You also cannot have 0 inside of a logarithm, and we'll talk about that coming up here. So let's go ahead and try numbers 2 and 3. We notice both of these are already written in logarithmic form with the log by itself. So for number 2, my base is 25. I'm going to exponentiating by raising both sides, or making both sides have a base of 25 and making both of those equations as exponents. 25 to the log base 25 is inverse operation, so they undo each other. On the left-hand side, then, I would be left with x. On the right-hand side, it's 25 to the 5/2 power. So again, the 25 is the base. So now we can go ahead and write this as the square root of 25 to the 5th power. And so this is going to end up being 5 to the 5th power, which is 3,125. Before I make sure that that is my final answer, I do that by plugging it in. I plug in 3,125, and that actually works. I don't have a 0 or a negative inside my logarithm. Let's try the next one here. My base is x for this one, so I'm going to exponentiate with a base of x. X to the log base x cancels each other out, undoes each other. On the right-hand side, we have x to the 3/2. So now what I want to do in exponential form is get x by itself. So I'm going to use a 2/3 exponent to get that x alone. So 3/2 and 2/3, those are, again, inverse operations. I'm just left with x now on the right-hand side. I can take the cubed root of 27 and square it. Cubed root of 27 is 3, and 3 squared is 9. So overall, plugging that back in, just making sure that makes sense. Log base 9 of 27 equals 3/2. That works out. We are good to go. So now let's take a look when we have why negatives don't actually work. So if you were to look at this exponential equation on the left-hand side, 3 to what power equals negative 3. And you're trying to think about what x could be. 3 to what power gives you negative 3 as an answer? Nothing works. You can't figure out anything there that's going to work. If you think about your graphs, y equals 3 to the x is an exponential. It's going to look like this. You're kind of trying to figure out, well, where does that graph cross down here when y is negative 3? It doesn't. Your range was from 0 to infinity for that one. So it's never going to give you negative 3 as an answer. So if we were to look at this as a logarithm, notice on the right-hand side, this is the exact same thing. 3 is our base, negative 3 is the answer, and x is the exponent. So looking at this logarithmic, you should look at this and think, well, this doesn't make any sense because in exponential form, it doesn't make any sense. So this does not actually work. You would have no solution. So therefore, this key takeaway right here, you cannot take the log of negative numbers or 0. You cannot take the log of 0 for the same reason. Like 3 to what power equals 0, it just doesn't work. Okay? So this is why we always have to check our answer and make sure that we don't have a negative inside the logarithm or it's not 0 inside the logarithm. So for example, let's go ahead and add a quick example over here. Let's do log base 7 of x minus 4 equals log base 7 of 2x plus 2. Okay, so for this one, our base here is 7. We're going to exponentiate using a base of 7. It's going to undo the logarithm on the left and give us x minus 4. It's going to undo the logarithm on the right as well and get us 2x minus 2, or sorry, 2x plus 2 rather. When we move the x to the other side and the 2 to the other side, we get an answer of x equals negative 6. But when we take negative 6 and we plug it into our original equation, we get log base 7 of negative 10 equals log base 7 of negative 10. So we get an answer that we think should work, but the big issue here is that there's a negative on the inside. So when that happens, when you have that negative on the inside or a 0 on the inside, you say, well, this answer should have worked. It does not work. Therefore, this one has no solution. That was an extraneous answer, an answer that we got that we thought. So let's keep on going with some other examples now. So we have 4 and 5 here. We have back to one logarithm in the problem. So we're going to go ahead and exponentiate using the base of the logarithm. So the base is 3. I'm going to do 3 as my base on both sides. On the left-hand side, I get 4x minus 17. And 3 to the 5th power, let's see, I think 243. Then we're going to add 17 to both sides. And then divide by 4. Oh, no, that's not an 8, that's a 65. There we go. When you plug this back in, 4 times 65 minus 17 is going to be a positive number, and it's going to check out. So x equals 65. Let's try the next one. Our base is 4. So we're going to exponentiate with a base of 4. We get 4 to the x plus 5 equals 256. Now coming out of our solving exponential equations unit, we can actually take and we can write both of these to have a base of 4. On the left hand side, we're going to leave it as 4 to the x plus 5. On the right hand side, 256 breaks down. It's actually going to be 4 to the 4th power. And so now what we can do is we can now, since these have the same base, we can set our exponents equal to each other and solve that equation. So we get x plus 5 equals 4, so x equals negative 1. Now, interestingly enough, you might be thinking, hey, that's a negative. It's not supposed to work. But when we plug it back in here, you end up getting a positive over there, and it's not even inside of the logarithm. So x equals -1 works, and this would be our final answer. Okay, now what we're going to do is we're going to go ahead and take a look at a couple with logs on both sides and ones that involve factoring. So for example 6, we're going to exponentiate by using a base of, by using a base of 3 on both sides. The logarithm and the exponential are going to undo each other. We get 3x plus 8 equals x squared plus x. We're going to move the 3x and the 8 over. Get 0 equals x squared minus 2x minus 8 when we subtract those over. We are now going to factor. We're looking for what multiplies to get -8, but yet adds to get -2. We get our answers of -4 and +2. Then what we're going to do is we're going to set these each equal to 0 and solve. And so we end up getting two answers. We get x equals 4 and x equals -2. Now, just because we end up with two answers here doesn't mean that we're going to, at the very end, have two answers. It all depends when we check our answers if they work or not. You might have 0 answers that work, 1 answer that works, or both of them might work. So we're going to plug in 4, and we end up with log base 3 of 20 equals log base 3 of 20 when we plug in 4. So 4 works. Then we're going to plug in -2 and we're going to see if that one works. So we get log base 3 of 2 equals log base 3 of 2. That one ended up working too. So both of these then would be our answers. So let's go ahead and try this next one. We have log base 12, so we're going to exponentiate with a base of 12. We get x squared minus 7 equals x plus 5. We're going to move everything to one side. We get x squared minus x minus 12 equals 0. We're going to factor x minus 4 and x plus 3. Set it equal to 0, and you get x equals 4 and x equals -3. Then after we get our answers, and we're going to check. And so if we plug in 4, we get log base 12 of 4 squared minus 7 is 9. And log base 12 of 4 plus 5 is 9. Oh, sorry, my pen's not writing. Let's try those again. Move it a little bit. Okay, so 4 ends up working out. If you plug in -3, you're going to get log base 12. When you plug in -3, you're going to get a 2 on the left-hand side and a 2 on the right-hand side inside of your logarithms. So -3 actually also works out, even though it's a negative number, it's not negative inside the logarithm. So both of these answers end up working. So again, you have to check them. You might get 2 answers, 1 answer, or no answers that work, and that's totally okay. Thank you very much, and I hope this helped.